So welcome to my webinar, How to Automate Testing in Pharma Industry, our Zwickröll solution for testing autoinjectors, pens, and pre-filled syringes. So my name is Tatjana Witterle. I will be your presenter for the next 30 to 45 minutes. My name is Tatjana Witterle. I'm working at Zwickröll since 2012 and for almost 4 years as a project manager in the sales department of automations. In this case, I'm responsible for the medical and pharma industry. And now I will start the presentation. I would switch off my camera for the webinar, so then you have a larger screen for the presentation. So one moment. Okay. So today I would like to give you an overview about all our possible applications for automated tests. So at the moment, we have robotic solutions for automated tests on autoinjectors, on safety systems, on pens, pre-filled syringes, and cartridges. You see it here on the slide. And in the next slides, I will show you our different solution in automation for these medical devices. For all our automated tests on different devices, we are using our robotic testing system, roboTest N, which you can see here on the picture in the middle. At the beginning, I want to explain you more about the general features of the roboTest N and before we go into the different application packages. So a really important point is our safety concept here. We have two doors, one in front and one on the side. It's always the same here, or normally it's always the same. And for every door, we have a safety switch for an extended safety door function between the robot and the testing machine. So that means that the doors cannot be opened during a test is running. Additionally, we have a locking lever in the docking mechanism of the robot. So the automation can only be started after all safety switches and the locking lever are locked. So this ensures a maximum protection for the operator, of course. So that means if the robot is unlocked from the testing machine because of manual testing or something else, daily checks, then the safety housing of the machine itself will be valid. Regarding maximum traceability, we have the option to implement a code scanner into the robot table. And yeah, we know it all in the medical industry that traceability is really important here. So we can read the data of the labeled devices as parameters into our software. So for all of our automations, we have our own automation software with the name Autoedition. So Autoedition is an intuitive software and it's really easy to operate. On the next slide, I will show you how Autoedition is looking like. We are using it mainly for starting and stopping the automation. And also for preparing the specimen. You see it on the next slide as well. But all of your test results are displayed as usual in TestExpert. So here on the slide, you can see it a little bit better how Autoedition is looking like. We have the Autoedition screen divided into a main area and a toolbar. In the main area, you can see the TestExpert operation window. So it's standard with all your set parameters, diagrams, and your results, for example. And the Autoedition toolbar includes a stop, a start, and a shutdown button, and also a button for the specimen office. And in the specimen office, you can create your specimen, as I mentioned before. So creating the specimen means how many samples do you want to test and at which row and place you want to start the automation. So now I would like to give you more information about our first application package. So in this case, the full automatic testing on autoinjectors. We have here an around line, and also the roboTest end system. So on the next slides, you will get an overview about the specific features on our robot table. Here in this case, with our drawer magazine, you see it on the picture, we can increase the number of specimen to 150. So that means 150 autoinjectors can be tested automatically without any interruption of the operator. So a few technical facts about the drawer magazine. We have 5 drawers for 1 tray each. So the advantage here is that a customer can use their own trays. But in the beginning, we have to test, of course, if the customer trays are possible at all. So regarding the tray size, or if there's enough gripping space between each autoinjector, for example. So if the customer has, or you as a customer has different device types and therefore different trays, then we have different gauges on each side to adjust everything really easy. So the drawers has to be filled up by the operator before he want to start the automation. So every drawer will be filled with one of their trays. So for an automatic run without interruption, there is an automatic beaker exchange required. So that means we have 5 empty beakers in the beaker tray, which is stored on the drawer magazine. You can see it here on the picture to save some space on the robot table because it's really limited there. We have 5 beakers with a capacity of approximately 100 milliliter. So our robot replaced the full beaker out of the testing machine and replaced it with an empty one from the beaker tray. But later I will show you a video where you can see it a little bit better. And after testing of the 150 specimen, the operator has to fill up the drawer magazine again and also has to empty the full 5 beakers. And then he can start the next automation again. So here on this slide, we have additional small magazine for not okay tested specimen. It's up to you, to the customer, if you want to remove the tested specimen back to the drawer trays, or all not okay specimen would be stored in this separate tray. In our opinion, we think it makes definitely sense to use the additional tray because in this case it's easier for you to get a fast overview of all bad devices really fast. So as I said, but it's only an option for you. It's not necessary. So this is one of our new features. It's an additional gripper, which is installed directly in a testing machine. So with this gripper, we can reduce the complete cycle time of the robot. So how does it work? The robot is picking a sample out of the tray. Then normally the barcode is scanned. You see it on the video on the next slide. The device will be placed into the testing machine. Then normally the test is starting. At the same time, the robot picks a second sample out of the tray, scans the barcode, prepares the sample, and places the device into this additional gripper. And then when the test in the machine is finished from the first device, the robot takes out the tested sample and places it back into the tray. And at the same time, the gripper places the second device into the testing machine. And then the test of the second device is started, and we have here parallel the complete process repeated. So now I will show you the first video of today. So here you see a full automated testing of autoinjectors. You see it here, the first autoinjector is removed from the first drawer tray. Then we have the barcode scanner here. Here, for example, you see an intermediate tray, which was our first solution for the cycle time optimization. But with the showed gripper on the slide before, you save a lot or much more time here. So then the first empty beaker is placed into the machine. So then the test will be started. We cannot see it here. And after the test, the robot placed the sample back into the tray. So in this case, we don't have a not okay magazine here. And normally after the full tray is tested, then the full beaker will be replaced. It's not really good here in the video because we have only see one tested sample, but normally when you test the whole magazine, then the full beaker will be exchanged. You see it here, it's a little bit slower because of the liquid inside. Yeah, and here you can see the drawer magazine up to 150 specimens are possible. So on the next package is for the safety system, so for the needle safety devices here. These safety systems can also be tested in the Autoinjector testing machine. So we have here special exchangeable parts for safety systems. So it's really easy to convert the testing device from Autoinjector testing to the NSD testing. So in this case, we have the same effort for changing parts as for another autoinjector device type, for example. The NSDs require special insert to be tested into the testing device. So therefore, we have a special design magazine, which is elevated for the reachability of the robot. So I will show you a video on the next slide where you can see it a little bit better in action. So all of our trays have their own 2D codes, not only for the NSDs, also for the autoinjectors, pens, and so on, which can be scanned together with other exchangeable parts with the Pokayoke scanner before starting a test. So here I will show you our second video. You can see it here. We have a capacity of, I think it's 30 specimen. Then we have the elevated tray. So the robot can really easy take off the sample and place it into the testing machine. And then the similar test like for the autoinjector can be tested here. So glide force, cap removal force. And then the specimen will be placed back into the tray. So here you can see we lock the lever on the side and then push the button, and it's easy to remove the robot table out of the machine, and then manual testing is really easy here. So now we have our third package. I give you more information about the full automatic test on pre-filled syringes and cartridges. So we have here the same principle like for the autoinjector roboTest N. So in general, as I said before, we have always two safety doors. We have one in front and one on the side. So you can use the side door for changing tools in a machine or do your daily checks. So it's not necessary to pull off the roboTest N from the machine. And the front door can be used for changing the magazine, for example. And also we have a movable robot table, as you saw on the video before. So with this, we ensure manual testing at any time. Here in this case, we have a special feature with a special table. This table has a docking mechanism and additional safety housing for the Zwicky line. You see it here. That means that an easy attachment for the robot is always possible. You see here the docking mechanism. We have here the same advantage as with the drawer magazines. So you, as the customer, can use your own production nests. So that means that the syringe nests can be used directly without any resorting of the syringes into another Zwick roll tray. On this robot table, we have a special holder You see it here on a picture. So the operator fills in the full nest into the holder, and the holder will push the syringes upwards out of their nests. So now it's really easy for the robot to grip the syringes in the right position. And we have here the possibility to handle up to 160 syringes. It depends on the size of the device, of course. So for the disposal of the devices, we have two options again. So the customer can choose if the tested syringes can be returned back to a second tray, like here on the drawing, or to be disposed in a container or by a chute, for example. So it depends on you. On this drawing, the tested specimen will be disposed in a second empty nest. You see it here on the picture, and it will be returned point symmetrically. The reason here is that we have a limited reachability of the robot gripper in this case. Here in the picture, you can see our cap removal station. So we have a possibility to remove the cap outside of the machine. In this case, no measurement of the cap removal force is required. We have here an active pneumatic gripper for holding the cap, and then the robot separates the cap from the syringe itself afterwards. The gripper opens and the caps are falling into the container. The container is also big enough for collect all 160 caps. And after the cap removal, the syringe will be centered at this station as well. But also I have here a video again, and here you can see the whole sequence. Then we have another possibility. We can use two test areas in one test method. That means that here in this upper test area, we can measure the cap removal inside of the machine, different to the slide before. And in the lower test area is for the measurement of the break loose glide force and also measurement of the volume. You see it here, it's with a scale. After the cap removal, the robot takes out the syringe from the upper part and places it into the lower part. So that's a really good advantage. You can use one test method and have two test areas. So now I will show you a video. You can see it here. The robot grips out the first syringe. And then we have the cap removal station. The robot drives upwards. And now you see it here how the robot is centering the syringe. And then we have the normal break loose glide force. You see it here, it's no scale and a bigger beaker because the volume test was not necessary here or not required by the customer. And now the break loose glide force test is starting. So here you can see our current roboTest N solution for automatic measurement of the stopper position in a cartridge. So the question is how to measure the stopper position. You can see it here on the blue box. We will measure the position from the top edge of the syringe to the top edge of the stopper with our video extend system. So our video extends will be handled as a testing machine. So this video extends will be run by test expert and it will be placed here on the robot table. You can see it here on the picture below. And when we are using Test Expert, we can guarantee a complete traceability of the test results. In this case, we can measure 20 syringes in 1 minute with our robots system. So here I will show you in more detail how the measurement is going. So the operator will fill up their nest into some holder, which you can see here on the picture. Then the automation can be started. So our robot with a vacuum gripper lift up the whole nest out of the holder and place it in front of the video extends. And we have here a kind of I would say, a metal block. You can see it here, which pushes the desired row, in this case 10 syringes upwards for the measurement. And then the video extend system can measure 5 syringes at the same time. That means that the robot is moving the nest from right to left, and then we measure the first 5 syringes, then the others. And after that, the robot moves the nest forward to test another row here. And the test duration itself is under 1 second. So last but not least, we have our last application package. It's for pen testing. So in this case, the needles will be screwed onto all pens by the operator before the automation is started. You can see it here in the picture. And we can use the same drawer magazine like for the autoinjectors as well. And then also 150 specimens are possible to test without any operator interruption. Here on this slide, you can see a picture of our cap removal station. We have here a pneumatic gripper, and this gripper can remove the housing and the inner cap of the needle if the operator is not allowed to do that. So, but the measurement outside of the machine, therefore we are not measure the cap removal force, and the caps and housings will be collected in this showed container here. So now I will give you more information about our priming station. So how does this station work? We have normally 2 selected units on the pen. These 2 selected units are enough for priming, so therefore the pen will be turned up with 2 units in the testing machine. And after turning up, the robot picks the pen out of the machine and bring the pen to a centric for shaking. You can see it here. The function of the shaking is to bring the air bubble to the top. It's the same what a doctor is doing. And after shaking, the robot places the pen with the needle pointing upwards into this upper part. And then the pneumatic gripper activates the pen button, and a light barrier detects if liquid is leaking. So here we have also a beaker, and the liquid will be collected in this small container beaker here. After the priming sequence, the normal dose or accuracy test in the machine can be performed here. So this station is on the robot table. It's outside of the machine. So now I have our last video for today. Here we have automatic tests on insulin pens. So in this case, we have a single tray, but as I said, drawer magazine is also possible. The robot picks up one device, place it into the pen tester machine, and then the dose accuracy test is starting. We have here, you see it here in the back, we have a video extends for optical number recognition. And after the test, the device will be returned back. For this customer, we had 2 test types. So we had a dose accuracy test, like you saw before, and a break loose glide force tests here in this case. We have some dummy printed pens, and in these pens we have filled up by the operator with cartridges, and then we have the normal break loose glide force tests here. This is also possible. Yeah, and here again the easy attachment of the robot to the testing machine. So manual testing can also be done really easy. So now I will give you a short summary of all the presented advantages and features of the roboTest N system. So first of all, it is a turnkey solution, so the customer can use the robot directly after installation and qualification. With the robot, we don't have any operator influence, which ensures reproducibility, so reproducible test results in this case. We have also several types of grippers. That means that every gripper, this grippers fits for a wide range of different device types like pens and syringes and autoinjectors and so on. Our magazines are exchangeable for different device types, so our Zwickroll magazines, but also you can use your customer trays. One important point here that the easy work will be done by the robot. Therefore, the operator wins more time for more complex work here. And all robots, as I said before, are running with our own software, Auto Edition, which is really user-friendly, and we have the flexibility for future applications. The movable robot table ensures easy access to the testing machine for the manual testing, and we can retrofit our roboTest N system to, I would say, to almost all testing machines, existing testing machines. So the robot table is really small in comparison with other robots, like a KUKA, for example, here. So we save here a lot of space in the lab or something else. And last point, yeah, we can integrate in barcode scanning for ensuring the traceability here. If you have any further questions, you can contact me directly or contact your sales and service team, and they will always help you. So thank you again and have a nice day. Goodbye.